Hi guys! Welcome back to my channel. Ready ka na ba mag-chemi? Para mag-chemi ng mga chemi? Subscribe to my channel now and then I'll be your chemistry teacher for today. Okay, so, hi, I am... Shh, it really hurts.
Okay, hi, welcome to part 2. Now we're going to discuss about accuracy and precision, okay? Ay, nabali di ay. Okay, so accuracy and precision. These are two concepts that have important uses in science, engineering, and statistics, as well as in other tasks such as baking. We need to be accurate. We need to be precise because what's the use of measurements of being inaccurate? That's why in laboratories and experiments we need to have many trials. And we're going to evaluate if the results are accurate or precise or imprecise, but nearly accurate, just like that. In research, this is a very an important topic to be understood, okay? So accuracy, first, it is a qualitative term used in determining the degree of conformity of a test result to a true or accepted value. Meaning, accuracy, doon siya sa pinakasakto nga value. Ako ra Bisaya, di ba? So in evaluating accuracy, we can use the mean, or also known as average. Okay, do you know the formula for the mean? Just simply add all the data and then divide on how many the number of the data. The summation of all the data from the it's just summation of all data divided by the number of the data involved. So the closer is the mean to the accepted value, the higher the accuracy of the data. Meaning, hapit ka masakto or mas hapit ma-accurate, and that is a very good for research. If your accuracy of your data is very closer to the mean of your accepted value. So another way of determining the degree of your accuracy is to use the standard error or percent error. Usually, this is from the absolute value of the difference between theoretical and experimental value, and it is just like this. But since errors are expressed in a percent error, so we can use this equation. The error is equivalent to the absolute value of theoretical minus the experimental value divided by the theoretical value times 100. And your answer is expressed in percent. Okay? Take note for that. If your accuracy is, or your percent error is nearly like 98% error, that could be a good result for your experiment. Or the very like ang accepted jud na kanang katuohan gid siya nga ang maximum jud nga ma-achieve sa usa ka experimenter is 95% above. And after that, below 95% error, meaning you need to identify the sources of the error. We are going to talk about the sources of the error later. So next we have precision. It is pertains to the consistency of achieving the same results repeatedly even if the value is far from the true value. Precision is just like pagkadugol-dugol lang sa mga value. Okay? To say that the set of data is precise means that the data are close in value to one another. From one another, there is no relationship between from the accepted value or the true value. Sa siya, as long as dugol-dugol sila, then you can say it is precise or the data are precise. So one statistical tool to measure precisions of a set of data is the standard deviation. This is describe how spread out the distributed data are, and they're always equal to or less than 1. The lower the SD value, the higher the precision of data. Okay, should be less than 1. Should be less than, more than 1 na siyan. Kako kita problema kay lagyo na sila gusa-gusa. LDR, like, lagyo. So this is the equation for the SDs, the square root of the summation of each data to the mean squared all over the number of the data involved minus 1. Okay? That is how you're going to calculate for the SD. you need to review your statistics. I think you're done with your statistics. Okay? So important note, this is one of the important note, replication or triplication of measurements must be done to improve accuracy and precision. That's why if you're going to have trials in an experiment, at least 3 trials. Mora na, di pwede nga, kaduha lang mag-trial. No. You can't measure the accuracy and precision in the trial or kausala. You need at least 3. Kay, mostly in laboratory experiments, mahal man ang yun na ano, di ka pwede nga kadaghan ka mag-test or mag-experiment. Kay, grabe ka mahal ang inyong mga chemicals or kanang sana mga agoy equipments involved. So meaning at least 3 lang, okay na ma-measure na ni mga accuracy and precision. And ato. Okay? So if you want to be more accurate and more precise or so that you can measure, make it more than 3 trials, like 5 trials, 10 trials. You have many time. Now let's go to before we're going to scientific notation, I want you to watch this video so that you can, this is like an analogy, so that you can relate. Okay? Para maka-relate mo, niya malingaw-lingaw sad mo, sige na magtanaw sa hunaw. Okay? Tanaw sa morning video. Okay? Okay?
A good scientific measurement is made with accuracy and precision. Accuracy tells us how close a particular measurement is to the correct value. For instance, how close is the reading of a thermometer to the actual temperature? Precision is the consistency of repeated measurement. In other words, are the results consistent each time something is measured? The more consistent the results, the more precise the measurement. It is possible to have a precise measurement that is not accurate. It is also possible to have an accurate measurement that is not precise. The best measurements are both accurate and precise. Let us look more closely at the difference between accuracy and precision using an archer and target. The archer is accurate when he hits the bullseye. He is precise when he can consistently hit the same spot on the target, in this case the bullseye, over and over again. This archer is both accurate, he hits the bullseye, and precise. He is able to hit the same area of the bullseye repeatedly. It is also possible for the archer to be precise, but inaccurate. If he misses the bullseye, he is inaccurate. He has missed the mark. But if he can consistently and repeatedly hit the target in the same place, even if it is not the bullseye, he is precise. On the other hand, the archer may be accurate, but not precise. If he strikes the bullseye, or right next to the bullseye, but his arrows are not consistently placed, then the archer is accurate, but not precise. In this case, the arrows would be spread across the bullseye rather than clumped together in a small area. If our archer is having a really bad day, he might even be inaccurate and imprecise. In this case, his arrows will strike the target in a random pattern, and he will not hit the same part of the target time after time.
Now let's go to scientific notation. Very familiar. It is a simplified expression of very large or very small number of quantity, and the standard form scientific notation is as follows. A times 10 raised to B. Sa scientific notation, naman dyan mga kwarta nga. For example, kwarta. Mga million, trillion, yan na. Or, gagmay na kayo, 0.000001. Error. 0.01234. Like that. We need to indicate it in the scientific notation so that we will not use that very crucial or basigma. Kuan inig suwat. We need to use scientific notation, of course. So in the standard form, we have A. It is an integer which is 1 to 9 only, na less than 10. Less than 10 siya ang scientific notation. Ang whole number dapat 9 point something lang. Okay? Kaya umabot kag 10, duha naman na siya ka digit. Dapat 1 digit. The first digit should be less than 10. Of course, right? First digit. Times 10 as the base, and the B here is the exponent or the power. Okay, power. Kapila ni mo gimove ang decimal point. So, for example, express 4,500 kilograms in scientific notation. So, since we're going to have the whole number in just one digit, take note that the decimal point in this value is here. The last part, next to 0, here is the decimal point. If we're going to move it to the left, 1, 2, 3, it means positive power. Sa katong being a form, okay? Padung left, positive power. But since we're going to have less than 10, we need to have 4.5. So we have 4.5 times 10. This is just raised to 3. Raised to 3 na. Kuwangan og 0. Typo error na sad. This is raised to 3. 1. Katulo raman ka. This is 1, 2, and 3. This is raised to 3 kilograms. Okay, sorry for the typo error again. Next, we have express 0.000008 milligrams in scientific notation. So if we're going to move the decimal point to the right, it means negative exponent or negative power. Okay? So, this I reveal. 1, 2, 3, 4, 5. Di ka pwede diha mo hunong. It's because 0.8 imong kuan, dili siya whole number. So we're going to move it here. 8, still less than 10. So we have here 8. Pwede 8.0, pwede rabog 8 times 10 raised to negative 6 nga nung negative 6 because we move the decimal point to the right 6 times. Then don't forget the unit, milligrams. Did you get it? Okay. Now let's go to significant figures. So there are the numbers of digit in a value. Often a measurement contribute to the degree of accuracy of the value. Aside from having the scientific notation, significant figures, scientific notation, for example, there are many figures involved. If we have the final answer, for example, 1.12345678910 times 10 raised to, no, we can use that, and we can just round it off to nearest 10 unless you are instructed to do the rounding off. But in significant figure, we can follow this in our exam. Okay, so significant figures are the figures that can be considered as that contribute to the degree of accuracy of the value. Okay, even though some of the final answers can exact, like round it off to the nearest tens or nearest hundreds, but we can also rely on significant figures depending on the given. Okay, and we have rules. And how are we going to identify the significant figures? So in dealing with significant figures, we're going to follow the rules. Number 1, okay, all non-zero digits are significant. Meaning non-zero, 1 to 9, oh, di ba, are significant. Pila sila. Example, 3556. Ipunan mo pila ka numero. Ang 3 significant, 5, 5, 1, 2, 3, 4 meters. It has 4 significant figures. Ipunan mo 1, 2, 3, 4. That's 4 significant figures. Next, we have all of these are non-zero digits. So you're going to count 1, 2, 3, 4, 5, 6. So there are 6 significant figures. Okay, all non-zero, automatic, significant sila. Number 2, zeros between non-zero digits are significant. So if a zero is natungan siya sa non-zero digits, automatic, that is significant. That zero is significant. For example, 900,008. So 90008. All of those zeros, 4 zeros are in between 2 non-zero digits. So that means all of those zeros are significant. So appeal sila sa ihap. Like 1, 2, 3, 4, 5, 6. There are 6 significant figures. Next, all of the zeros are in between the non-zero digits. 7 and 9 are in the terminals. Okay? Milli-Newton. So, you're going to count all of the numbers, all of the digits, not the numbers. 1, 2, 3, 4, 5, 6, 7, 9. So, there are 9 significant figures for this rule. Next, we have zeros to the right of a decimal are significant. To the right of a decimal, for example, kini. Basta zero gani, bisag na siya sa tumoy, wala siya in between. Basta as long as naka-indicate diha ang decimal point and right after the decimal point, it is considered significant. Okay? So for example, there are 6 zeros here. So apila sila plus kining usa ka non-zero. So 7 significant figures. Another, we have 897.00 megabytes. So we have 5 significant figures. Counter na nimo. Next, zeros to the left of non-zero digits are not significant, but are used to indicate the position of the decimal point. Okay, for example, to the left ha of non-zero digits, kini. To the left, wala man siya natungan, pero to the left. Kini siya, even though these zeros are right after a decimal, but since wala siya natungan og usa ka non-zero diri and there is no non-zero sa una niya, kining number 3, balik ta sa number 3, take note that zeros right after the decimal are significant if ang kinaunhan niya, if ang before the decimal point is a non-zero. But if it is a zero before the decimal point and then right after the decimal point are all zeros, they are not significant. Okay? It only indicates the decimal point. Indicates lang na siya, pero wala may non-zero diri Okay? So this has only one significant figure. This one has 3 significant figures. Next, last rule. When a number ends in zeros, the zeros could be significant or could not be significant. So in this case, we have here end terminal zeros. Wala siya right after sa decimal point. Kining tulo ka zero dali. Wala po siya natungan og non-zero. So meaning these 3 zeros in the end are not significant. So therefore, there are only 3 significant figures. The 7, 0, 9. Indicating the decimal point would make the zero significant if there is a decimal point at the end of the zeros. It makes it significant. Okay? So there are 6 significant figures. But another to consider significant figures, drawing a bar on the tip of zeros, kung naganing bar kung sa kana nga zero, it means those are significant. Okay, like this. The 2 zeros have a bar on top. So kining usa kay wala siya labot sa ihap sa significant figure. So there are only 5 significant figures. Okay? Nakuha. And you need to take note of that rules to count the exact number of significant figures following those rules. Now let's go with the operations with significant figures. In the addition and subtraction rule, when the numbers are added or subtracted, the number of decimal places in the final should be equal to the smallest number of decimal places in any of the measured quantities. There are, for example, mag-add or subtract. There are, for example, 3 quantities being given. And you should identify first which of the following have the smallest number of decimal places. For example, 1.0, usa ra yang decimal place. So you should kanang refer sa imong final answer sa kadtong decimal point. Ang imong final answer should have at least 1 decimal place lang pod for addition and subtraction. Okay? If ang kinagamit niya nga decimal place based sa given is duha, so duha pa sa final answer. If wala, di wala po sa final answer. Okay? Decimal place ang sa addition and subtraction. For example, we have here the given 64.00, 50.005, 34.0 meters. Which of the following has the least decimal place? We have here 34.0, right? So, kung imo na silang i-add, mo come up na siya into 148.00.5 meters. But then, ang iya ramang decimal place nga least is 0 decimal place. You need to round this or to indicate this into i-transform na nimo into 1 decimal place only, which is 148.0 meters for addition and subtraction siya. Now let's go for the multiplication or division rule. When multiplying several quantities, the number of significant figures in the final answer is the same as the term with the least number of significant figures. Take note for this multiplication ha. Least number of significant figures sa given. So sa multiplication division is siya. If there are, for example, 11, 102, 1. So which has the least significant figure? The 1 significant figure. So your final answer must base from that least significant figure. Okay? Example. Determine the area of a table with a length of 10.2 cm and a width of 11 cm. How are you going to identify if it's multiplication or addition or division? This is area. So you need to multiply this to quantities here. So which of the following has least significant figures? So this 11 centimeter having 2 significant figures. Kaya ang 10.2 centimeters, 3 man yung significant figures, right? So if you're going to multiply it, the product will be 112.2 centimeters squared. But then there are only 2 significant figures for the least significant figure from the given. Your answer should be 110 centimeters squared. 110 has only 2 significant figures. But then you can also express this into scientific notation. 1.1 is also having 2 significant figures. Okay, nakuha? And that will be all for today. Thank you for watching. See you for the next chapter. Bye!